A 500 kVA three-phase 50 Hz transformer has a voltage ratio, line voltages, of 33 to 11 kV, and it is delta star connected. The winding resistances are per phase on the high voltage side is 35 ohms. Per phase on the low voltage side is 0.876 ohms. The iron loss is 3050 watts. Our task is to calculate the value of efficiency at full load and 1/2 load, at unity power factor and at 0.8 power factor. The transformer winding ratio A is given by the voltage across the primary winding, line to line, over the voltage across the secondary winding, line to neutral, which is 33,000 divided by 11,000, which is divided by the square root of 3, and that is all works out to 3 times the square root of 3. The primary per phase resistance referred to the secondary side is 35 divided by 3 times square root of 3 squared, and that equals 1.295 ohms, and is added to the secondary per phase resistance of 0.876, which gives us the total of 2.172 ohms. The secondary phase current is equal to the transformer kVA divided by the per phase secondary voltage. Plugging in our actual values, we get 500,000 divided by root 3 times 11,000, which works out to 26.24 amps. The full load copper loss is equal to 3 times the secondary phase current squared times the total reflected secondary resistance, which is equal to 3 times 26.242 squared times 2.172, which equals 4,490 watts. Since the iron core loss is 3,050 watts, the total full load loss is equal to 3,050 plus 4,490 for a total of 7,540 watts. We will now return to our task where we have to calculate the value of efficiency at full load with A, unity power factor, and with B, 0.8 power factor. Also, at 1/2 of full load with A, unity power factor, and B, 0.8 power factor. Starting at full load, since the current is in phase with the voltage, the real power, kilowatts, is equal to the kVA times the cosine of 0 degrees, or 1, which gives us 500 kilowatts. For an electric motor, efficiency is the ratio of the mechanical power delivered by the motor output to the electrical power supplied to the motor input. The motor input is simply the motor output plus its losses, which, plugging in our known values, we get 500 divided by the quantity 500 plus 7.54, which equals 98.5%. For electric motor at 0.8 power factor, efficiency is the kVA times 0.8, which is equal to 400, and we get 400 divided by the quantity 400 plus 7.54, which equals 98.1%. At half load, for an electric motor at efficiency, we get 1/2 times 500 kVA times 1, which equals 250 kilowatts. At half load, the copper losses, I squared R, is 1/2 squared times the full load copper losses, and that is equal to 1,222 watts. Therefore, the total half load losses equals 4,172 watts. You will have noticed that we have reduced the copper losses because of the reduction in the low current, but we have maintained the full iron losses. This is due to the fact that regardless of the amount of current that is flowing due to the load, the magnetic flux is always the same. The power out at a power factor of 0.8 is 200 kilowatts. The efficiency, again measured by the output power all over the output power plus the power losses, and plugging in our actual values, we can calculate the efficiency to be 96.1%. Ready to go beyond just solving problems? If you've been following my daily post and enjoying the sample problems, you're going to love this. All of these problem sets and more are now available, or soon will be, on my official course site, my Standstore for Electrical Training. Just go to the web address that you see at the bottom of this slide, https://stand.store/GVB. In recent years, the reality of climate change has become impossible to ignore. Severe weather events are growing more frequent and more intense. For homeowners, this means that utility power outages are no longer inconveniences. They can last for hours, days, or in extreme cases, even longer. The question is no longer if, but when. You'll need a solution to keep your homes powered and your family safe. Now is the time to prepare and ensure that you're not left in the dark when the next storm hits. Here are some trusted resources to help you prevent power outages at home. Jackery Canada at this web address, Jackery USA at this web address, Bluetti Canada at this web address, Bluetti USA at this web address, and Bluetti Australia at this web address. And finally, you can get EcoFlow at this web address.